this video from the fourth problem in exercise 8.4. So this is that 9 secant square a minus 9 tan square a. What is the value? As you would have predicted that we can substitute into of secant square a. We can put using the identity, again starting with the identity 1 plus tan square a is equal to secant square a. I will substitute the value of secant square a is equal to 1 plus tan square a. So now I will get 9 into 1 plus tan square a minus 9 tan square a. So this is equivalent to 9 plus 9 into tan square a minus 9 tan square a. So now you can see that 9 tan square a, 9 tan square a will get cancelled. So answer is 9. So this is simple application of the second property. Then I will go to question number 4th one, B part. This is the first part. Second part is 1 plus tan theta plus secant theta whole bracket into 1 plus cot theta 1 plus cot theta minus secant theta. Secant theta. So I'm going to continue here. What happens is, now I'm going to expand it. So it is better to write everything in terms of sine and cos. So I'll begin like this: 1 plus sine theta. Tan theta is 1 by tan theta is sine theta by cos theta plus secant theta is 1 by cos theta. So I can write it like this: 1 plus, this is cot theta is cos theta by sin theta, this is 1 by tan minus, sorry, this should be cosecant. This should be cosecant here. The question so this reads as 1 by sin theta. So now taking LCM, this side it is a cos theta, so cos theta plus sin theta plus 1 divided by cos theta into, again sin theta is LCM, so sin theta plus cos theta minus 1 divided by sin theta. So now what happens is, that if you consider this step, you might think that what is the problem here? You might think there is no way you can simplify this, but if you observe this term clearly, if I assume that cos theta plus sin theta is equal to some value, Suppose I assume it as x. So now in this equation of the form will be x plus 1, numerator of form will be x plus 1 into x minus 1. So you would have guessed it. This is a identity we can use, that x plus that is a plus b into a minus a plus b into a minus b is equivalent to a square minus b square. This is an algebraic identity. So using that I can write this as directly x square minus 1. So x square is nothing but cos theta plus sin theta whole square. So now let's simplify. Cos theta plus sin theta whole square is equivalent to sin square theta plus cos square theta plus 2 into sin theta cos theta. So this you know that using the identity, this is a 1, this will turn out to be equal to 1. So I can write it as, so this I can write this whole numerator, I can write it as 2 cos theta sin theta plus 1. Then it is, this is a x square, so then it is minus 1 here. So similarly the denominator is cos theta into sin theta. So if I simplify it, this both will get cancelled, 1 minus 1 is 0, so 2 cos theta sin theta. So I'll continue in this side. Less space. So this is simple now. It will get cancelled. 1 and 1 minus 1 is 0. So remaining term in the numerator will be, will read as 2 cos theta sin theta by cos theta sin theta. So now if I cancel this 2, it is answer is 2. So for this question answer is 2. So this is, I think, most easiest method, but if anyone find a much better and simpler method, you can just comment it below. So now I am going to continue with the third question. So third question is secant of A plus tan A into 1 minus sin A. What is the value of this one? So this is what is the question. So now again this one is, I can directly write in the form of sin and cos. So 1 by cos A plus sin A by cos A into 1 minus sin A by 1. It is better to write by 1, sometimes don't confuse and multiply in the numerator denominator. So cos theta, cos A and cos A both are same, so I can directly write the numerator as 1 plus sin A into 1 minus sin A divided by, so cos A into 1, so cos A, the numerator doesn't change. So now I can write it as, again the same formula, a plus b into a minus b is a square minus b square. So I can write it as 1 square minus sine square of a by cos a. So now again 1 square is 1, so 1 minus sine square a. So again, if you recall the property that sine square a plus cos square a is equal to 1, then if I take the cos square to right hand side, then sine square a is equal to 1 minus cos square a. So if I use this, if I substitute this in the numerator instead of sine square a, I'll get it as 1 minus whole. So it is better always when there is a minus sign, it is better to put the bracket 1 minus bracket of 1 minus cos square a divided by cos a. So now taking the bracket out, so minus into 1 is minus 1, so 1 minus 1, so minus into minus will become plus, plus cos square a by cos a. So this 1 will get cancelled, so cos square a by cos a, which is equivalent to, if I can, this is in the form of, this is square term and this is not a square term, so directly I can remove the square and cancel the denominator. So this is cos a. So this is simply as nothing but don't get, like suppose x squared by x is there, so using the powers and exponents rule, that is base is same but the powers are varying, so it will be equivalent to x of 2 minus 1, so this is 2 minus 1, so this is equivalent to x. So this similarly cos a. So now I am going to fourth question. Question number 4 and part 4. So this is 1 plus tan square a by 1 plus cot square a. So this is nothing but what I can say is, this is very simple. Directly again using the property, we have to remember the two properties, the three properties actually. 1 plus tan square a is secant square a, and directly I can substitute it. So 1 plus cot square a is cosecant square a. So it sometimes that cosecant can be written as CSE, cosecant of a. Okay. So cosecant of a, 1 plus cot square a is equal to cosecant square a. So now again if I substitute directly, so it will be, numerator will be secant square a by denominator will be cosecant square a. So now again here, no need to worry here, there are easier to simplify this. So we know that, again we know that 1 by cosecant, 1 by cosec a is nothing but sine, and also 1 by secant a. I can also think like that, 1 by cos a is secant of a. So now I will substitute this. So if there is a square term, then 1 by cosecant square is equal to sine square a, and 1 by cos square a is equal to secant square a. Now if I substitute this here, so I can write this as secant square a into 1 by cosec square a. So if I substitute instead of sec 1 by cos square a into sine square a. So now bringing this together, equal to sine square a by cos square a, which is nothing but, again I can write this as sine a by cos a whole square. This is nothing but sine a by cos a is tan a square. So this is what is done, tan square a. So now remaining problems I am going to continue in the next video, and thank you.